Hello, everyone. Today we're going to continue with development of the atom or structure of the atom. The two scientists today are J.J. Thomson and Rutherford. We're going to start with J.J. Thomson. Before we start, I think I have a short, where is it? Oh, just a short video.
Late in the 19th century, in 1897, another scientist by the name of J.J. Thomson hypothesized that atoms are made up of even smaller particles. Thomson conducted experiments in which an electric current was passed through tubes pumped almost empty of air. You observe. What do you see when the electric current passes through the tube? You can see that light is given off. This light is created by rays traveling through the tube. Thomson observed that when a magnetic charge is introduced, the rays are deflected. Thomson reasoned that the rays were made up of negatively charged particles. Today, we call these negatively charged particles found in atoms electrons. Thomson also hypothesized that positively charged material existed in the atom. In his model of the atom, he proposed that an atom was made of a positively charged material in which negatively charged electrons were scattered. His model of the atom became known as the plum pudding model. He envisioned small electrons embedded in the atom, much like raisins embedded in a plum pudding. And about the same time, Henry Becquerel, Pierre Curie.
All right, so let's go back to Thomson. So the experiment, there are three things you need to know. The experiment he conducted was called the cathode ray experiment, and he used the cathode ray tube. And another thing you need to know is the radiation or the beam streamed from the cathode to the anode, which is going from negative to positively charged. So he conducted the cathode ray experiment, and he concluded that there's a negative charge equally distributed with the positive charge throughout the atom. He proposed the plum pudding. The dough itself is positively charged, but the negatively charged is scattered, just like chocolate chip or raisins in plum pudding. Okay, so that's his vision. It's scattered charges throughout the atom. Okay, next is Rutherford, and I also have a short segment.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
All right, so for Rutherford, his experiment is called the gold foil alpha particle experiment. The beam goes through the beams that goes through, that means they went through empty space. But when it deflected or bounced back, that means it hit something or repelled when it hit a charge. So he concluded that inside the nucleus there are protons and neutrons, and all the positive charges are concentrated in the nucleus. The nucleus contains all the mass. So inside the atom, the positive charge, and that's when the alpha, because the alpha particle is positive, and when it hits the center, which is positive, it repels and bounces back. Okay, um, and then also concluded that it's mainly empty space because a lot of the particles just went through. The tiny negatively charged electrons travel around in a cloud. So he his vision of the atom is the nucleus is positive and the electrons just revolve around it. So the center is the nucleus, electrons circle around it, not just scattered. There's a center and orbits, not scattered electron, just like J.J. Thomson. All right, and that's our two scientists for today. Uh, we'll see you next time.